Hello, first we introduce ourselves. My name is Masayuki Kitano from Wakayama Medical University.
Hello, my name is Yasunobu Yamashita from Wakayama Medical University.
We are very happy to introduce our recent publication entitled Usefulness of a newly designed laser-cut metal stent with an anchoring hook and thin delivery system for EUS-guided hepaticogastrostomy (EUS-HGS) in experiment settings. Please explain the background and aims of the present study.
Recently, EUS-guided biliary drainage has become the method of choice for patients with malignant biliary obstruction in whom endoscopic transpapillary drainage fails. EUS-HGS is indicated in these conditions. However, the rate of adverse events associated with EUS-HGS, such as bile peritonitis and stent migration, are higher. Particularly, stent migration and bile leakage are severe adverse events of EUS-HGS. The dilation step using mechanical dilator or coadal device can cause bile leakage, the onset of bile peritonitis and abdominal pain. Difficulties in this step can result in failure of stent insertion and migration of the luminal side of stent into peritoneal cavity can cause fatal bile peritonitis. Therefore, efforts are required to reduce or prevent procedure-related adverse events during and after EUS-HGS. More convenient and safer devices for EUS-HGS are therefore needed. We developed a partially covered self-expandable metal stent with thin delivery system. The aim of present study was to evaluate the feasibility of this newly designed stent with anti-migration anchoring hook for EUS-HGS in phantom and animal experiments.
We would like to explain the feature of this metal stent. The width of this metal stent is 8 mm. The length of this stent is 100 mm. It is equipped with uncovered part. The length is just 10 mm, and also it is equipped with hook, 3 hooks at the luminal side of the stent. The maximum diameter, including this hook, is approximately 20 mm. This structure of hook works as the prevention of migration. This is the delivery system for this metal stent. As you can see, this has equipped with the tapered tip and also thin delivery system. The diameter is just 7.2 French, which facilitates to insert without fistula tract dilatation. Although the largest part of this delivery system was 2.4 mm, its tip was just 0.94 mm, which is smaller than the 90 gauge needle. This video shows the hook structure creates an anchoring effect and resilience to return to the original position, even if it is drawn. Please explain the study design.
Present study aimed to measure the maximal resistance force to migration in phantom and ex vivo experiments and to assess the feasibility and safety of EUS-HGS using newly designed stent with peaks.
Please explain the results of the present study.
In the phantom experiment, the median maximal resistance to stent migration of both the proximal and hook sides were significantly higher for hook than conventional stent. In ex vivo experiments, the median maximal resistance to stent migration on both gastric and hepatic sides was significantly higher for hook than conventional stent. All EUS-HGS procedures were performed successfully with hook stent and conventional stent, with none of these animals experienced procedure-related severe adverse event. There was no significant difference in technical success or adverse event between conventional and hook stent. On the other hand, the success rate of EUS-HGS without using a fistula tract dilation device was significantly higher with hook stent than conventional stent. Microscopic findings detect the insertion line of the stent between the stomach and the liver, and fibrous tissue with re-epithelialization growing around the fistula site of the stomach and the liver via Masson trichromo staining.
Finally, please summarize the present study.
The newly designed hook stent may prevent stent migration and peritonitis because they show strong resistance to migration and skip dilation step in experimental setting. Therefore, these new stents may be feasible and safe for EUS-HGS.
Thank you.